So when we look at a rational inequality here, we are looking to get everything on one side of the inequality, so it's greater than or less than 0. And then we want to get common denominators and all the things, all right? And then we split things to find what I called key numbers, I think, in the video. But let's just baby step our way. So the first thing I would do here is move that 4 over, okay? So I have 3 over x plus x over 1, right? Minus 4 over 1 is greater than 0. Now I want a common denominator of x. That means I have to multiply this one by x and this one by x. Does that make sense to everybody? All right, so the 3 is going to stay a 3. X becomes x squared, and this becomes minus 4x. Still greater than 0. Get it on one side, common denominator it, and then we split it. All right, we're going to split the bottom. Come over here. Because we can't divide by 0, you're going to say the bottom cannot equal 0. Sometimes there's further solving to do, sometimes there's not. But in this case, no. That just means in the solution, 0 is not in our solution. Okay? Then I take the top. And I'm going to put this in exponent order. So it's x squared minus 4x plus 3. And let's treat it for a second like it's equal to 0. How can we solve this? This is just a quadratic. T-chart, okay. So multiply to 3, add to a negative 4. What would work? Negative 3, negative 1. It does work since this is a 1x squared. I can put them straight into the expressions. And then I solve each of these. So x equals 3, x equals 1. Now, these are my key points on my number line. So I have 0, 1, and 3. Now, go back to your inequality and look at this. Will it be open circles or closed circles? Open. Whatever's on the bottom is always going to be open, but this one tells us that the tops are always open as well. Okay? So open circles indeed. Now comes the time when you have to choose where are you shading, because you've got a lot of stuff going on here, right? And we want it to be greater than 0. So greater than 0 translates to positive values. We want positive values when we plug in for x. So what you would do is pick some points in the different sections. See how it's got sectioned off between 0 and 1, 1 and 3, and all the extremes? So let's pick some points like, let's pick a, what do you feel like picking? 2, maybe?
2.
Sure. 2 falls between 1 and 3, right? So let's pick a 2. Let's plug in a 2. F of 2. And what I'm going to do is plug it into, you can plug it into the original equation, or you can plug it in right here where you've gotten the common denominator. That's sometimes easier. Okay? When I do that, I get 3 plus 2 squared minus 4 times 2 over 2. So if we algebra this out, plus 4 minus 8 over 2, negative 1, no. Yeah, negative 1 over 2, right? Mm-hmm. So really all I care about is that that came out to be negative. Now let's pick a number adjacent to it, like a 4. Okay? If I plug in 4, I'm going to do the same thing. 3 plus 4 squared minus 4 times 4 over 4. Minus 16 over 4, All I really care is that this came out to be positive, didn't it?
Yes.
here's where you can use your calculator, or you can keep plugging in numbers. All right? Because what this is telling me is that when I plug in an x, the y values are negative. When I plug in a 2, my y values are negative, which means it's under the x-axis, right? When I plug in a 4, that means my y values are positive, so it's above the x-axis. So if I look at my calculator, I'll switch over real quick and I'm going to put this equation in, y equals, clear that out. And I'm going to put it in with my fraction the way I have it here. So 3 plus x squared minus 4 over x, right? And then I graph it. Now I'm going to zoom this in because I want to see where my key points fall. So at 0, notice that my graph goes way up the x-axis. It's never really going to touch it. That's an asymptote. That's why our circle is open. All right? Now, at -1, and everything above, did we miss something here?
I think you forgot the x
in the equation?
Mine does not look like that.
Oh, I did forget the x, didn't I? I was like, something's wrong. Now is that right? Oop. Okay, much better. But still, that 0 is going on. Now, everything to the left of 0, where is my graph? It's below the y-axis, isn't it? So that tells me that if I plugged in numbers, it would be negative. Well, what's happening then between 0 and 1? Where's my line? Is it above or below? Because this is where 1 is, right? Between 0 and 1, are my y values positive or negative? Positive. So I can either use my graph or plug in values. Does that make some sense? All right, great conversation. Okay, let's look at this. Now, well then how do you know where your answer is? Well, you're going to look at your equation. I want greater than 0. And we said greater than 0 is positives, right? So I'm going to look at my number line where I put my plus signs. These are my solutions. So my answer will look like this. It'll be a parenthesis, 0, 1, and then it comes over here, parenthesis 3 to infinity. So there's a lot of steps here. So confusing? Yeah?
Yeah.
It's a lot of steps. It is a lot of steps. I know that. That's what makes this section a little challenging, not impossible, but challenging. All right? Like I said, you do not have to do this piece. You can just use your graph. What you're going to find is 90% of the time, these signs will alternate. So if you do one section, you can kind of figure out the rest. There is a chance it won't always alternate, so that's why I want you to at least check on your calculator, graph it. Okay? So, like if it didn't alternate, then like if you were looking at the graph, it would do something like this. It would bounce off and go back up. See how that worked? That's the situation in which it wouldn't alternate. Those signs wouldn't alternate, but it doesn't happen very often. All right? So let's try another one. Baby step our way through. All right, what do I need to do first here? Move the 6 over. So 4x plus 3 minus 6 over 1 is greater than or equal to 0. Now what? Get a common denominator. Yep. So 4x plus 3 stays the same, but I've got to multiply that 6 times x plus 2. You good? Now what? Distribute. Let's clean up the top here. So 4x plus 3 minus 6x minus 12 over x plus 2, still greater than or equal to 0. If I collect like terms in the top, I have negative 2x minus 9. Huh? Okay. Now we split it. The bottom cannot equal 0, so take what's on the bottom and say it cannot equal 0. So x cannot equal a negative 2. So there's one part of my answer. Okay with that? Then I take the top. The top can equal 0. So we want to find out where does it equal 0. So let's do that. So x is at negative 9/2. Okie doke. This one only, excuse me, only has 2 key points. So I have negative 9/2 is what, like negative 4.5? So it's over here. Think a second. Now, what kind of circles am I putting on these? On both of them?
No. Open. Closed and open.
Oh, no.
This one can equal 0 because it's from the top. And it would be closed because the original equation has an or equals to. The 2, however, since it's in the denominator, it can never ever be 0, so we have to leave it open. So this is the scenario when, even though it's a less than or greater than or equal to, it's still an open circle. All right, special case here. Hi. Oh my goodness, all for me. Yes. Thank you. Now, we've sectioned it off. Now we need to test our values, right? What value would you like to plug in?
-1.
-1 sound good?
No, negative 3.
Something between these two? Yeah. -3 would fall in here, right? So let's try out a -3. Let's just see. So I'm going to take it from this stage and plug in a -3. And see if it comes out positive or negative. That's all I care about. -2 times -3 is 6 minus 9 gives me -3. -3 plus 2 gives me -1. So what's my end result going to be? Positive. So that means I have positives here. So my assumption is what?
That's it.
The others are
Negative.
the others are negatives, okay? So how do I check myself? Well, I go to my graph. Here's -2, here's -9/2, okay? Something's happening. It should be looking like this in some way, okay? Actually, that's not true because it can't hit -2, right? We said it can't hit -2. So let's back that up. It's doing this. And then something's going on over here. That is keeping it all negative. All right? It's just a guess based on this. So let's look at it in the calculator to double check ourselves. See if I can type it in correctly this time. -2x minus 9 over x plus 2. Does that look about right? There's my -4/2, right? To the left of it, it's negative. To the right, it's going positive. Until we hit -2, and then everything's negative. You see it? So use your graph to help yourself. Is that okay? No? Jazzy, don't see it? So we're looking at making sure the y values here on the graph match what we thought it would be here. So remember, this is like -4.5. So at -4.5 to the left, my y values are below the x-axis, so that means they're negative, right? So that's correct. What's happening between -4.5 and -2? Right here to here, they're all above, which means my y values are positive. You seeing it? All right, and then at -2, what happened? everything jumped back down below the y-axis, so that's negatives. Do you see the connection here? Okay. So then, I have the signs correct, but which part of the number line then is my solution? Go back to your original. It says greater than 0, which translates to positive or negative? The positives. So there. This section is my solution. So then I would write it like this. I would say bracket -9/2 to -2 with a parenthesis. Is that okay? Yes, this is a lot of steps. We're just putting little steps together for one big question. Okay? All right.